This is a disc brake, and you'll find two of these slowing down just about every new road and gravel bike currently on the market. Today though, we're looking specifically at brake pads. These little buggers can cost you anything from a tenner up to over £50 to replace. And as if you actually ride a bike, these will need replacing fairly regularly, we thought we'd look at what gives you the best bang for your buck. Let's get into it. Shimano Ultegra is one of our favorite group sets in the world right now, and you'll find it on loads and loads of mid to high-end road bikes. Like all disc brake group sets though, use it enough and your brake pads will need replacing, something that can be quite a costly endeavour. A replacement set of these Shimano LO5A RF brake pads will set you back £24 a pair. Chances are you're going to need to do front and back at the same time, so you're looking at the best part of 50 quid. You might, while searching for the best deal, stumble across some cheaper alternatives and wonder if they're worth trying out. For example, these Aztec brake pads have an RRP of £12.99 per pair. They're not alone either. These Uber bike, I think this is the Race Matrix material, which is said to offer a whole new level of braking power and pad life. They cost just £10.99 a pair, or even less if you buy a few sets at once. There are also plenty of premium brake pads on the market. I mean, lots of us like to upgrade every other part of our bike, so why not this one too? These are SwissStop's 34 RS brake pads, again compatible with Shimano. They're also more expensive, £27 a pair, but they do claim to not only offer improved braking performance and have silent operation, but also extend service life. So could they work out as better value? And finally, we have Sinter's K-type pads. They've got the green backing. This is the choice of Team EF Education EasyPost and a fair few other World Tour teams. They're also targeting the premium end of the market with an RRP of £26.99. So, are half-price brake pads any good? Is it an area that we should be spending more on? Should we be paying more attention to this often overlooked bike component? Well, we spent countless hours trawling through Google to try and answer these questions, but we soon found that there's really not a lot of information on the matter, other than a few rudimentary tests. And so we decided it was up to us to do some science. There was a slight issue though. We've tested all 5 sets of these brake pads in the real world, and with constantly changing conditions and more variables than you can squeak a brake at, it's almost impossible to tell which are best. We therefore set about trying to find a proper rig. Turns out they're properly expensive, and nearly all brake pads are manufactured in Asia, which is quite a long way away. After wearing them down though, we managed to convince Sinter, one of the only companies that manufacture brake pads in Europe, to lend us one of their very fancy brake testing machines. First though, let's take a closer look at the pads on offer. Brake pads come in a few different varieties. One's made of organic material or sintered brake pads, which are usually used in poor conditions and sacrifice some performance for extended service life. All of these pads we've got here are organic. That is what most people opt for on their road bikes. But as you can see, each brand chooses to do it differently, and they all have a different compound to deliver that combination of braking power, bite, modulation, temperature resistance, and wear life. Actually, saying that, the Uber bike ones and the Aztec ones, they do look very similar. Nearly all of the pads use a steel backing plate. That is all of them except Shimano, which uses aluminium, and it also has these fins, which are there to act as a heat sink. As you can imagine, a lot of a disc brake's job is to try and dissipate heat. Too much heat and you get brake fade. Really though, it's the disc that does the bulk of the heat dissipation. The larger the disc, the more surface area there is to transfer this heat to the environment. And as braking is basically friction and transferring kinetic energy into heat, that's really important. Now, we're going to do all of our tests on Shimano Ultegra discs because that's a really common option. And so we've got 22 160mm rotors. Thank you, Madison. Now, coming back to the pads, and immediately you will notice some differences. So looking at the friction material, you can make friction material from all sorts. And as you can see here, they all use different materials to get that same end result. So the cheaper ones, the Uber bike and the Aztec pads, you can see it's a really similar pad material. It looks like it's a copper brass mixture, potentially some graphite in there, that's the black bits. It's going to be an all-round pad for general application. So we would expect these top 3, or top 2 at least, to be, they're more race orientated, so with higher bite, but potentially less wear resistant. But we're going to do some testing and find out. Another thing that's interesting, or I find it interesting anyway, it's quite nerdy, the Bike pads are on a 1mm backing plate, whereas all the others are on, well, at least 1.5mm backing plates. And they've also got 3mm of friction material. So the bit you can actually use is 3mm. Now that sounds like a really good thing, although I highly doubt, because of that thin backing material, that you can actually use it all. I think that your pistons will run out of fluid in effect to push them any further before you use all of that wear material. So again, could be a false economy. We've measured all the other pads and they all appear to have about 2.4mm of friction material and about 1.5mm of backing plate, which, yeah, that seems to be about the norm. We've measured them as accurately as possible using our digital calipers, but the paint can add a little bit of thickness, so plus or minus 0.1mm. One thing that I find quite interesting, and you might not, but feel free to skip this bit, is that all these brake pads are designed to do the same thing, and yet the materials involved are just so different. Any brake pad is made up of 5 components to make a polymetrics composite. Those 5 components are an abrasive, so the bit that actually generates that friction, a lubricant, which, I mean, crazy that you need a lubricant in a brake pad, a filler, and then you've got a resin / a binding material, and then you've got fibers, which can be either organic or non-organic. So for example, Kevlar, carbon fibers, steel fibers, that sort of thing. The resin is really important, and that's probably the main reason for these different colors of pads, because they're all phenolic resins. And the resin has a really important job because it's not only got to be temperature resistant, it's got to have good binding stability, it's got to have a good wear ratio, but also it's got to reduce NVH, and that is noise, vibration, and harshness. And that is sort of one of the reasons that we're doing this test, because you might think, why do I need my brake pad to have more power? And yeah, fair enough, the limiting factor could well be the tire on the road. However, if you don't have powerful pads, then chances are they will vibrate, they will heat up too much, and then you'll have really annoying squeaking brakes. And that's what happens when you ride and you get water or oil. You take away this third layer because all the braking happens between the pad material and pad material. So you've got to transfer pad material onto your disc and a bit of disc material onto your pad. And it's that third layer that does all the braking. And when you get oil or water, you basically wash that away, you contaminate it, and that's when you get all that noise and not very good braking. Now, on the topic of noise and vibration, squeaking brakes happens when you hit a resonant frequency because of our vibration. What I didn't know was all the braking happens in a third layer. So not necessarily on the disc, not necessarily on the pad, but on a third layer between the two. When you bed in your pads, you transfer some of the pad material onto the disc, and you transfer some of the disc material onto the pad, and it's this third layer that is really important. Now, when it's wet or you ride through some oil or grease or muck, dust and gravel, the problem is you contaminate this third layer, or you just wash it away, and then you need to re-bed in your brakes. And if you don't have enough braking power, if you don't have enough friction, then you get this vibration and then it squeaks. So even though the limiting factor sometimes is the tire on tarmac, if you don't have enough friction, then you get noise, and that is something that we don't want. So we're going to be testing all of these pads for not only their endurance, but also their friction capabilities. Let's go and have a look. So what we're going to do is take our 5 brake pads and do 3 different tests. First, we have the enduro brake test. This will measure the time of deceleration, as well as the friction coefficient from a speed of 30 kph down to 15 kph for 20 cycles. And then a further 20 cycles from 30 kph to 0 kph. This test will basically tell us how fast each set of brake pads will enable us to stop in an emergency situation. Each time we're applying a brake lever force of 40 Newton meters, and every time we're changing the disc to a brand new disc, hence why we've got so many. Once we've done that, we'll move on to the second test, and this is going to be a wear test. This will take quite a bit longer with many brake cycles, and we've chosen to do this in mixed conditions, mainly because we're from the UK. It's unlikely to be sunny for 2 days in a row. What that means is that we'll do 50 cycles in the dry and 50 in the wet on repeat for 350 brake cycles. Then we'll measure the thickness of the brake pads when they come out to see how fast each pad wears in a controlled environment. We'll also note how noisy each pad gets. Now, we can't use a decibel meter for this because of the machine itself is quite noisy, but we'll use a little scale and report back. The third test is called the fade test. The point of this is to see how much a brake pad decreases in performance during repeated use. This will simulate a long mountain descent where brake pads are feathered on and off for 5 minutes, 30 down to 5 kph, 30 down to 5 kph on repeat, then they cool off and then they go again for another 2 5-minute blocks. Now there is one thing left to say, and that is that this isn't a commercial video. Of course, this is Cinta's machine because, well, you try and find a brake testing machine that doesn't belong to a brake pad company. Here at road.cc, we have gone to every length to make this as fair a test as possible. We've decided all the testing programs, the speeds, the tests that we're actually doing, and we've purchased all of these brake pads. What we probably should have done though is made the tests a bit shorter because they're going to take some time. We'd better get started. So after many days, the testing is complete. So let's take a look at some results. So first up, we have the performance test, and we have all kinds of useful data such as the system pressure, the disc temperature, the braking torque, and the deceleration time. As you can see, there are some significant differences between the brake pads. And if we take a look at the average braking torque from 30 km/h to 0, then it's the premium brake pads that lead the way with the higher forces. What this means is that when you plot the deceleration times on a graph, you get this, with the Uber bike pads taking just over 5 seconds, then the Swiss stop pads, then a solid effort from the Aztecs, and then a bit of a jump down to the Shimano pads, and then another jump to the Cinta Green 2032 pads, which might give you an indication of why some pro teams have been switching. As you'd expect, we see almost exactly the same thing with the 30 km/h to 15 km/h deceleration test, but there is another interesting bit. Take a look at these maximum disc temperatures. Despite those fins, the Shimano pads saw higher maximum temperatures than the rest. Both sets of our premium pads performed well in this regard, and it was another solid performance by Aztec. Braking performance is one thing, but there is of course a lot more to a good brake pad than that. On to the wear test, and this is where things get really interesting. On this table, you can see the volume and weight of friction material lost during the test. Just as a reminder, we simulated a wet environment to try and speed this up a bit, but it did still take a very long time. Looking at the results, you'll quickly realise that there's a negative correlation between the braking performance test that we just looked at and wear resistance. The softer the material, the quicker it will wear. With this in mind, we have the Shimano LO5A pads once again taking the middle ground, with the Cinta pads losing more mass and hence wearing faster, but nowhere near as fast as the Swiss stop pads. The most hard wearing pads with almost identical test results were the cheaper pads from Aztec and Uberbike. So to answer one of our questions from the beginning, no, cheap brake pads won't necessarily need replacing more often. Potentially the opposite, in fact. There is one catch though, and that was the noise. Due to the noise of the machine, it wasn't possible to use a decibel meter, but there were some really clear differences. The semi-metallic formulations of the Aztec and Uberbike pads may have been harder wearing in the wet, but they were far more noisy. In order of noisiness, from most noisy to quietest, well, it was a direct correlation with how quickly they wear. Uberbike and Aztec, then Shimano, then Cinta, and the Swiss stop pads were the quietest. And our final test was the brake fade test, simulating some really high temperatures. In excess of 350 degrees centigrade in fact,
and then seeing whether the friction coefficient dropped off a cliff. Here we're looking for the higher the number, the better. The maximum friction coefficients always happened when the temperature was lowest. Makes sense, right? These results pretty much follow those of test 1. As things heat up though, we see a few pads switching position. The Cinta pads saw the least drop off. The Shimano pads started well, but saw a significant drop off when things got hot. The Swiss stop pads dropped off less, but the distance between the Aztec and the Uberbike pads narrowed. Now, it is worth noting that semi-metallic pads dissipate heat better, but can fade faster due to the oxidational process. So, in conclusion, should you spend more on your brake pads? Well, as always, it depends. Firstly, I would say stick with a reputable brand like we've got here. We didn't have any issues with any of the 5 pads we tested during testing, and it's an understatement to say that brakes are important. There's plenty of horror stories about the friction material coming off of backing plates, and it's just not worth it no matter how cheap the pads are. Secondly, I think what we've learned is that brake pads are a compromise. No matter how good they are, it's impossible to have a class-leading braking performance and be hard-wearing and be quiet, but I think there's a place for all of these brake pads. Shimano, probably fairly sensibly, has in nearly all cases taken the middle ground. They didn't win any of the tests, but neither were they the worst. When it comes to premium brake pads, there are some really tangible benefits. And I'm not just saying that because Cinta let us use their fancy machine. Lots of people upgrade every other component of their bike for better performance, and you can definitely add brake pads to that list too. There's some decent gains to be had, and it's no wonder that pro teams who are trying to eke out every gain are opting for faster wearing but higher performing brake pads like the Cinta Green 2032s. And actually, this testing, if it's shown me anything, I reckon I'm going to upgrade my brake pads for the summer when you experience less wear anyway. As for the cheaper pads, well, the Aztecs in particular probably did better than I expected. If you're often riding in the wet and want to prioritise durability over outright braking performance and noise, then it's an area where you can save quite a bit of cash. There is just one more thing to add, and that is that properly bedding in your brake pads will make an absolutely huge difference to their performance. And so whilst I was at Cinta, I thought I'd have a go on the World Tour's new favourite bit of equipment. Expect to see plenty of these at this year's Tour de France. Did you expect there to be this much difference? Let us know in the comments below, as well as which brake pads you'll be buying. If you enjoyed this type of content, then please give us a like, subscribe to the channel for lots more bike tech, and we'll see you next time.